Hello, PreCalc. You'll be watching this after class on Friday, and I hope the whole board is in. Let me check and see. Looks like it might be. I'll adjust it if I need to. It turns out that we did some special triangles, and from those special triangles, I've sketched them up here in the corner. The special triangles are 30, 60, 90, and 45, 45, 90. And from that, we can do all of these trig functions now. Without a calculator or any other aid, we can do sine of 30, which is also pi over 6, cosine 30, tangent 30, and then we can do the same for 60 and 45. 60 is also pi over 3, 45 is also pi over 4. So we can also do the other trig functions, which are the reciprocals, the secant, cosecant, and cotangent. So those are what's up our sleeves so far, but we're going to stuff a lot more in there today. So we keep them up our sleeve, which means they're always there with us, and we never have to look them up or anything. They're just available to us. To do that, we're going to develop what's called the unit circle. When you take notes on this, it has to be pretty large because we put a lot of information on it. So draw a large circle. Alright, I hope that doesn't look like an egg or something. And imagine this is round. If it isn't, I think it's a little lopsided. That's alright. And I want you to divide it not in half, but not that way. Let's go this way. And first of all, I'm going to get my phone and time this. I know it's going to be more than one part, and it might be one that goes on into 3 parts. I hope not for your sake, but I'll do the best I can. Alright, so let me get the timer going. Stopwatch. And I think I'll do alarm. So I'll stop at 12. Timer, I'll stop at 12 minutes. So I probably blabbed already. A couple minutes. You have a nice big circle on your page, divided in half this way. Alright, so we have learned in the past that this is 0 radians and it's also 0 degrees. And so that's our starting point. Here's the center of the circle. And if we go all the way around like that, we've gone 180 degrees, which I am going to write the degrees here and the radian measure here. It doesn't matter, I just picked that. So we know that halfway across is 180 degrees or pi radians. So I'm going to go all the way around the unit circle, teaching you the radian measures at every spot. But I'm going to do the first half first. So I'm going to divide, as you are, this top of the pizza, half of the circle, into 6 equal slices. You can do that by dividing it in half, and then each of those halves, which are a quarter of the whole circle, into thirds. So can you make 6 equal pieces in the top of the pizza? So the top has 6. Those are the spots that I'm going to name by radian measure. So if I start from 0 and I end at pi, does it make sense that 1/6 of the way over to pi is 1/6 pi? So 1/6 pi is the radian measure for that first stopping point, that first slice. Now we don't write it, that's not cool at all. That's why you write in pencil. Pi over 6 is how you write 1/6 pi. So this is 1/6 of the way over to pi. 1/6 pi, 2/6 pi, 3/6 pi, 4/6 pi, 5/6 pi, and 6/6 pi, which is 1 pi. So let's go back and write them in. 1/6 pi, 2/6 pi reduces to 1/3. Or pi over 3, 1/6 pi, 2/6 pi, 3/6 pi. Seeing what we did here and here, write that one in. 3/6 is 1/2 or pi over 2. And we actually have talked about that one before. 1/6, 2/6, 3/6 pi, 4/6 pi, but 4/6 can be reduced to 2/3 pi, and the cool way to write it is 2 pi over 3. 1, 2, 1/6 pi, 2/6 pi, 3/6 pi, 4/6 pi, 5/6 pi, written 5 pi over 6. 6/6 pi we've always taken care of. Now we need to draw in the pieces on the bottom half of the circle, and they are an equal sixth as well. So I like to cut it in half like that, the half in half, and then each of those into thirds, whatever way you think. I want 6 equal pieces on the bottom half of our circle. And we're going to continue the dance of the pi. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6 pi, 7/6 pi, which is 7 pi over 6. 8/6 pi, which reduces 4 pi over 3. So we were at 6/6 pi, 7/6 pi, 8/6 pi, 9/6 reduces by a factor of 3, 3 pi over 2. So we've met that one before as well. 6/6 pi, 7/6 pi, 8/6 pi, 9/6 pi, 10/6, which is 5/3. 5 pi over 3, and after 10/6 is 11/6. No reducing, 11 pi over 6. All right, have you got the radian measures around? Hopefully you have. Let us go ahead then and put in the degree measures as well. And here we have 0. A sixth of the way over to 180 would be 180 divided by 6, or 30. So we're going to count by 30 degrees and put in those numbers. So this is 30. Notice I'm not writing on the outside of the circle. There's a reason for that. So hopefully you're doing this like I'm doing it. 30, another 30 is 60 degrees, 90, 120, 150, 180 is already written in, 180, then we have another 30 is 210, is that right? Another 30, yeah, and then another 30 is 240, another 30 is 270, 300, and 330. And we'll go around all the way and call this also 360. It can also be called 360. This in radians can also, once we get all the way around, we know it's also known as 2 pi. So we've got all the way around now in degrees and radians. The last thing we need to add to the unit circle will take a little more thinking, but it's not impossible. In fact, you will be able to create this unit circle all by your lonesome. So, coming along for time. Okay, doing well. All right, so I want you to put in these spots first, and we're going to name the coordinates. So imagine this is on a coordinate plane. A unit circle, the word unit, like unit multiplier, always has something to do with 1. So where is the 1 on the circle? The unit circle means it has a radius of 1. So the radius goes from here to here. So any of these spokes on the wheel, the distance from the center to the circle is 1. So I'm going to grab a triangle out of this piece of pie. So I'm going to grab this one, and I'm going to pull it out over here. So when I do that, because the radius of this circle is 1, do you see that this part is 1? Alright, so the red circle, the red triangle has been pulled out over here. So the degree here we mentioned earlier when we were going around is 30 degrees. And that is one of our special triangles. Is it still up there? Can you see? Yeah, you can. 30 degrees is right here, and the special parts with the 30-degree triangle are 1, 2, square root of 3. So the one that we learned is 30 degrees. It was 1 across from the 30, and the hypotenuse was 2, and then this was square root of 3. We learned that last lesson with a special triangle. So this is a 30, 60, 90 degree special triangle. This is also a 30-degree triangle, and it's also a right triangle. So how do we change these values to match the unit circle? Well, every 30-degree triangle, right triangle, the parts are proportional to every other 30-degree right triangle. So the one in our picture only has a 1 here, where the one we learned last night has a 2. So and yesterday when I taught that lesson, I mentioned the word proportional to. I didn't make a big deal about it, but I did use it. Did you hear it? Well, the proportionality comes out to play now, because this is the 30-degree triangle, special triangle relationships, and every 30-degree triangle, right triangle is proportional. The sides are proportional to these. So we know if this 2 became a 1 in our picture, then these must also be cut in half. So 2 became 1, 1 became 1/2, and square root of 3 becomes square root of 3 over 2. So we knew that because we had one of our dimensions, and then we just made the others proportional to the relationships we knew had to exist. Alright, so with that in mind, can you get the value of this point right here? And so we're going to go over so long and up so long. Well, according to this triangle, we have the answers. We got over square root of 3 over 2. So to get the name of a point that is plotted on the coordinate plane, you do the amount you go right and left. This went right, square root of 3 over 2, and the second coordinate tells you how far up you went. So the right-left coordinate, and then the up and down coordinate. Alright, so I'm going to get rid of that, because these two numbers are going to repeat themselves all the way around the circle. So let's see how that happens. Here, right here, I'm going to eyeball that. Maybe there's a third color. I'm not sure if the video picks up the changing colors very well, but we'll go ahead and try it. So here, I'm looking at this triangle and trying to get the values, how far over to get under this point, and then how far up to get to that point. And it turns out that we're going to use these same values, but they are going to flip. Here we go over 1/2 and up square root of 3 over 2. So this is 1/2 over, and this is up square root of 3 over 2. And these values will do this kind of dance except on the 4 points that I had you do, and we'll fill those in last. Alright, so we're going to go over here to this one. If you're going to try to use 1/2 and square root of 3 over 2, you need to remember this is the short guy, and this is the long guy. So for the first one, we went over the long guy and up the short guy. Then on the second one, we went over the short guy and up the long guy. So does that lingo help? How would you get to this point right here? Well, we're going to make a triangle. We're going to go from the center over and up. You see? Yep, there's my timer. I'll finish this point, and then we'll start part 2. So right here, do you see we went back meaning negative, the shorter distance, the short guy, and up the long. So we went back negative 1/2 and went up positive square root of 3 over 2. Alright, I'll grab some more points on part 2.